In this video, we're going to look at solving inequalities graphically and using function notation. And I'm going to start with a graph of a quadratic, and I'm going to use that same quadratic to look at a few different cases where we have less than or greater than. How do we tell the difference and what's happening with it, okay? We'll also look at just solving an equality too with function notation. What does that look like? So the graph of y equal f of x is given. We see it here. Solve f of x less than negative 2. Okay, so remember that f of x is a y value. So you can almost think of that as saying y less than negative 2, all right? So it's saying where are the y values on the function less than negative 2. So what I'm going to do, I'm just going to draw a line right here. I'm going to dash it in here at y equal negative 2. All right. So with this statement, f of x less than negative 2, what it's really asking is, okay, where is this function below that dotted line that I just drew, y equal negative 2? Okay. And what are the x values that make this statement true, f of x less than negative 2? So let's draw this right on the graph so it's real clear. So I'm going to put open dots right there where that graph crosses the line y equal negative 2, because I have f of x strictly less than negative 2. If I had less than or equal to, I'd fill them in, but I don't want to include those points, but I want to include everything below that line that's on the function, right? So I'm just going to shade the function where it lies below that, right? F of x less than negative 2. Okay, so when we're talking about this solution of this, we want the x values that make that true, right? So what are the x values? So the lowest one would be negative 4, right? Strictly less than x, strictly less than, what's the x value at the top end there? 0, right? Okay, so the solution set would be negative 4 to 0, right, in interval notation. Okay, and again, I'm using the open bracket. I'm not including negative 4 or 0 in this interval. There are open dots there on the graph as well. Okay, so hopefully that's making sense, and that's a nice way to think about it. If you can shade the appropriate part of the graph and then ask yourself, what's the domain of that piece I just shaded? That will give you the solution. All right, so let's look at another example. This is the same graph, right? It's the same parabola we were using, but this time we're asked to solve f of x greater than or equal to 4. Okay, so with that same concept in mind, I've got y greater than or equal to a number. So that number in our case is 4. So I'm going to put a nice little horizontal line there at y equal 4. And I want to know, where is this graph above that line, right? Because I have greater than or equal to 4. Okay, so I'm going to shade that piece, and it's greater than or equal to, so I'm going to put solid dots right where it crosses the line y equal 4, and then shade everything above it, right? We have greater than or equal to. All right, so the part that I'm shading in green is the part that lies above the line y equal 4. Ask yourself about the x values where that's true. So essentially, what's the domain of the green thing that I just shaded, right? So because we've got arrows shooting off into the sky, I would say that we have x less than or equal to negative 6, right? Everything to the left of negative 6, or everything to the right of 2, or x greater than or equal to 2, okay? So in interval notation, we're going to have a solution set of negative infinity to negative 6, close bracket, in union with 2 to positive infinity, right? So it's okay to have more than one interval, right, when you're solving an inequality like this. In this case, we ended up with a compound inequality. And again, I just want to reiterate, shade the part that applies, right? And then ask yourself what the domain of that is, because that's really what the solution set was, right, that we stated. Okay, so with this same graph, solve f of x equal to negative 4. Okay, where is negative 4? Down here, right? Okay, now I want to know with an equality, where does that line cross, right? What are the x values where those intersect? And it only intersects once, right? At x equal -2. Okay, so the solution set is -2. I'm just going to put it in little set brackets there, okay? Okay, so we may have a value, like if I picked a value of f of x equal 4, we would have had two solutions to that, right? So it's okay for it to have more than one, but in this case it only intersects in one place, right? At x equal -2. So now I want to solve a three-part inequality graphically. Okay, so now it's saying solve -2 less than f of x less than or equal to 4. So again, I'm going to put little horizontal lines here at -2 and then also up here at 4. And I want the stuff that's between there, right? So we're saying -2 is less than f of x is less than or equal to 4. So we're saying f of x is between -2 and 4. So where does that happen? All right, so at y equal -2, we have open dots, right? Because we have -2 strictly less than f of x, and we have less than or equal to at the other endpoint of 4, right? Okay, so I'm going to shade the stuff that happens between these two lines, right? All right, so once you have that part shaded, like I said, look at what you shaded and then ask yourself, what is the domain of that piece, right? What are the x values where that occurs? So I'm just going to start writing the solution set because I know I have two intervals here, right? And the lowest value of x that I'm going to have is -6, and that's a solid dot there, so I'm including it, right? Up to -4, and that's an open bracket there, in union with the other interval from 0 to 2, right? And I'm not including 0, but I am including 2, okay? Very nice. Okay, so and just another piece of this to review a little bit, find the domain and the range. Okay, so it's a quadratic. We've got arrows pointing up in both directions, right? So the domain here would be all real numbers, right? Nothing limiting there in terms of the x values. What about the range? The range is a little limited, isn't it? What's the lowest y value on the function? Well, -4, right? And we're including -4. And then this just has arrows pointing into the sky, right? So -4 to +infinity.